thank you very much. It's a pleasure to be here. My job at this point in the afternoon when everybody's blood sugar is low or all feeling a little drowsy, I'm supposed to wake you all up by talking about economics. So that's a little bit of a challenge, but we'll see what I can do. And in fact, it's really great to follow Kevin, because 2 weeks ago, Kevin sent me an email. He said, hey, what's the value of search? What's the value of the web for finding answers to questions? And I said, Kevin, you're really in luck. That's what I'm going to talk about before this group in a couple weeks. So let me launch into it. Now, of course, when I say the economic value of Google, I'm not thinking just about Google. It's not, if I said what are the economic value of libraries, I'd be thinking about the libraries and the books and the circulation, the readers, all this stuff. So I'm thinking about the value of the whole ecosystem. If you want, think of this as the value of search in general, or the value of search on the internet. But there's a couple different ways to look at that. I'm not going to try to say what would the world look like without search engines, or what alternative histories would be like. What I'm going to do is I'm going to try to quantify the value of search, or the value of Google, in two dimensions. One is what you bring to advertisers and what you bring to users. And the way to quantify that is to try to look at the value that advertisers are getting from search engine advertising, and look at the value that users are getting by using search engines to answer their question. And of course, this is inherently a back-of-the-envelope exercise. I'm not going to do things to 2 or 3 decimal points. If it comes within a few billion, I'll be happy. So I'll give you a little model of a value of Google to advertisers. I got to warn you, there is an equation here on the next slide. When I wrote a book once, and my editor said, you know, every equation you put in a book cuts its sales in half. So I'm kind of worried that when I get to the equation, half the audience is going to get up and walk out. But let's see how it goes. So the general idea is advertisers, they have a value per click, and that pretty much has to do with the profit they make on the sales they have. There's a number of clicks, there's a cost of the clicks, and they want to maximize profit. The value of the clicks times the number of clicks minus the cost of the clicks. And that value can include all sorts of other things that I'm not going to go into now. And suppose you got an advertiser, he's getting a certain number of clicks, he's spending a certain amount of money. Well, he could cut his bid. Could cut his bid down to X hat, he'd spend less money. And if he's making the right choice now, then the profit he's getting now would be better than the profit he would get by cutting his bid. And as soon as you write down that statement that the value of the clicks minus the cost of the clicks is at least as big as the alternative, then you get this nice little bound that says the value of clicks has to be at least as big as the incremental cost. And the logic is really just econ 1. I could cut my bid and move down. That would save me some money, but I'd lose some clicks. And if I don't want to move down, then the value of those clicks that I lose must have a higher value than the money I would save. So it's just looking at that comparison. I could do something different. If I don't want to do that, then I've got to have some inequality on the value of clicks. But how do you know how many clicks you get if you bid less in the auction? Well, you could experiment, or Google's got this tool called a bid simulator. And what the bid simulator does, it basically reruns the auction from last week, and it says what you would have gotten last week if you did something differently, just by going over and simulating what the outcome of the auction would be. So if you decrease your bid, you move down in the rankings, we can estimate how many clicks you get from being in that lower position, and then we can see how much you'd have to pay based on the rules of the auction, and that gives you a pretty good estimate of what the relationship is between clicks and cost. So once you get that lower bound in clicks, then you can kind of plug back into that value formula, the value of clicks times the number of clicks minus the cost of the clicks, and you can calculate the value-cost ratio. So that's like your ROI, your return on investment. And if you go through all that stuff, we have a few computers at Google, so we're able to do this calculation. And it turns out the value over cost ends up being 2, so somewhere around 2. And if you think about that, it says the ROI on that advertising is 100%. Well, that's crazy. I mean, how could you have an ROI that's 100%? That's huge. But the answer is go back and look at those auctions. Because if an auction is oversold, that's when you have a whole page full of ads, which on Google is 11 ads, then the competition is really intense to get on that page, and you have to bid close to your value in order to get your ad shown at all. But if you have an auction that's undersold, that has 2 or 3 ads on it, well, then what happens is the competition is much diminished, and you end up getting a real bargain. Because in the extreme case, where there's only 1 ad on the page, you don't have to compete for being on that page at all. You just have to pay the reserve price, and the reserve price ends up being quite a small amount compared to the value. So it turns out that, in fact, this ROI is pretty reasonable, because only about 1/3 of the pages have ads, and only when you go to those pages, the average number of ads is around 4. So for most of the pages on Google, the competition isn't very intense. If you're selling an idiosyncratic product, kind of the long tail sort of thing, then you get tremendous value out of it. And when you go advertising over all those auctions that are very competitive and all those auctions that are not very competitive, well, this ROI is not too implausible. In fact, what happens is almost every advertiser would like to have more clicks at the price they're currently paying. So in general, you can, the constraint is in the number of queries or the number of things that people are asking, not so much on anything else. So now we've got an idea of how to get to the value of clicks, but that's not the end of the story, because you also get all those free clicks. You get all those free clicks from the organic search results. So if you look at that, it's roughly advertisers get about 5 times as many free clicks as they do paid clicks. And then you're getting back roughly 7 times what you spend if you look at the ad clicks, which you're paying for, plus your organic clicks. And what else do you want to add into this calculation? Well, the publishers are getting revenue from Google. That's the AdSense revenue. And then we have a nonprofit program where nonprofits get the value search services are provided to them. So if you add up the total value to the advertisers, the total value to the publishers, the total value to the nonprofits, in the US, you get about $54 billion. So it's a pretty big number, and that's just the commercial value or the advertising plus publisher value alone. So if you want to follow us up, well, you can Google it. We released all these calculations. We look at a state-by-state basis, and you can look at those numbers yourself if you want to pursue it. Now, the second component I talked about was looking at the value to the users. And then you want to ask, how much is search worth to users? Well, you might say, how much would you pay to give it up? Right? If I went out and said, hey, I'm going to pay you, you can't use a search engine for a year, how much would you require that I pay you to give up search? So there's a nice little paper from some faculty members at University of Michigan. It's called A Day Without a Search Engine. And what they did is we gave them some queries that people type into Google, and the Professor Chen took teams of students and divided them up into 2 groups. One group went to the library and tried to answer those questions, and the other group went to a search engine, in this case Google, and tried to answer those questions. And then she got the answers to the questions. She had a board evaluate how accurate they were and tried to measure the time savings from using a search engine versus conventional technology. And notice that these students started the exercise in the library, so they didn't have to get in the car, drive to the library, and do anything like that. They could just start right there and try to answer the questions. Well, it turns out that without the search engine, it took about 22 minutes to answer the average question, and with the search engine, it took about 7 minutes, so it was saving people roughly 15 minutes today. Now, there are little subtleties here, and I want to bring those out because not everything that people type into Google is really comprehensible. You don't know what it is. So she divided the questions into those that were answerable. So there was the query, where in the world is swine flu? And she translated that into a specific question for the students. Is there a map where I can see where swine flu has been diagnosed? And the same thing for these other questions I listed up there. And then there were some things that were just not answerable, TV shows on the internet, TechNet, Teacher Day, MySpace comments. Couldn't figure out what that meant, so that fell into the unanswerable list. And there are also lots of questions on the web that people ask that are kind of self-referential. They only refer to things that show up on the web, so those were ruled out as well because you couldn't really plausibly imagine you could answer those using the library. Now, there were about 2,500 searches, and there are about half of them that were answerable using a library. And if you eliminate all the duplicates, you got about 350 searches, and they were classified into these different kinds of searches: factual, source, web, and other. And then they went through and tried to convert all these to questions that people could actually answer. And when they went to the library, they could use the reference room or the library stacks. They could consult the reference librarian. And then once the questions came up, they were rated by raters, and then they took an average of the quality of the questions that were answered. And so 99% of them were answered in the web treatment, about 90% in the library treatment. And by the way, it is important to recognize that these were questions that people ask on the web, so they were expecting to get answers. You'd also try to look at questions that people would ask to a reference librarian or expecting to get library answers and see how many times you could answer those on the web. And this is a number I gave you earlier. It took about 7 minutes to answer questions on the web, 22 minutes on the library, and you got almost the same quality of answers. And hey, guess what? The students liked the web better than the library. What a surprise that was. So now the question is, once we know how much time you save, that 15 minutes a day, then let's try to convert that to value terms. So this is going to be a little bit of a economic challenge, but hey, we'll see how it goes. So save using the library was 22 minutes. Time using the web was 7 minutes. So if you ask how many times do users do a search a day, well, rough answer is 1. And remember, the answerable questions, the one you could conceivably answer using a library, that would be about half a question per day. And think about what happened before the web was around. Well, now people are asking billions of questions a day to that search engine. And before, to all intents and purposes, they were asking far, far fewer questions than billions. So back when it was really expensive to get answers, you didn't ask so many questions because it was a big deal to get up and drive to the library and try to get those questions answered. But now that answers are cheap, we ask all sorts of questions, all sorts of questions. Some are sort of silly and frivolous, but some are really important. Same kind of questions that people were asking 20 years ago. So this is what we call a demand curve for questions. When it took you 22 minutes to get an answer, you ask very, very few questions. And now when it takes us 7 minutes to get an answer, you ask a lot of questions. And if it took you only 3 minutes to get an answer, you probably even ask more questions. So we think of a little demand curve where we have price in terms of time on the vertical axis, and we have questions on the horizontal axis. And then what we try to do is we try to calculate what's called the consumer surplus, which is the value of those answering those questions, the time saved over what the technology was like in previous times. So it turns out if you do that, and of course I am going to wave my hands a little bit here, you try to convert that time savings into money savings. So the average hourly wage is about $22. You're saving about 3.75 minutes a day. That's $1.37 a day. And just as a little gut test, ask yourself, would you pay $1 a day to use Google? Well, yeah, it's worth $1 a day or $1.37 a day, but this audience is an audience that asks a lot of questions, right? So it's pretty clear that for this audience, the value that you would have to using a search engine would be at least $1 a day. You add that up over 365 days a year, that's about $500. And now if we look at the number of users, well, I used the wage rate, so you could say, let's use the employed population, that's about 130 million people. Or you could use the entire population, that's 300 million people, and you get somewhere between 65 billion and 150 billion, depending on which of those numbers you actually use. So roughly speaking, if you want to figure out, if you want to say how much is Google worth, well, if you think it's worth about $1 a day for the average user, the typical user, then that translates into those numbers that I described a minute ago. Now, there have been various other attempts to try to pin down a value for the internet. Bob Litton and I did a study of productivity impact of the internet. McKinsey has done some work on this, and the McKinsey numbers come out pretty close to what I just described, namely around $1 a day, and they got that from basically survey evidence rather than doing the time savings approach that I used here. So, in fact, this is a little picture from the McKinsey report that shows you the demand curve in terms of the stated willingness to pay, how much you'd pay to have these services available. So I think I've got one more slide here. And if you look at the little summary, the value to the advertisers plus publishers, the commercial value, around 50 billion. If you look at the value to users in terms of time saved, around 65 billion. And taken from the McKinsey study, I didn't talk about it here, the value of all the ad-supported applications is around 25 billion. So those are getting to be pretty big numbers. Not like the national debt or anything like that, but still they're fairly significant from an economic point of view. Now, I've left out the cost of trips to the library. I've left out the unanswerable searches, I mean, celebrity searches and things like that. I've left out the value to the non-employed people, the value that people are being able to get from finding just that right product because of the product variety available on the internet, the entertainment value. All that stuff has been left out, so you should think about these numbers as an underestimate of the true value. But no matter how you cut the cake, the value of search, the value of the internet, the value of being able to get answers to questions immediately, that's a pretty big deal. So I'll leave it there. Thank you.